Right, so the question that I chose to do for the exploration problem is section 9.3, question number 87 on the Taylor series. It's a different approximation strategies, and it says that suppose, because you don't actually want to, so it wants you to suppose that you want to approximate the third cubed root of 128 within 10 to the negative 4 of the exact value. So, and it wants us to take the Taylor polynomial of the function of x of 125 plus x to the 1/3 power centered at 0, and then the Taylor polynomial of the function of x equals x to the third centered at 125, and then it wants us to evaluate it and compare the two approaches. So I have my work pulled up right here. So for a, the function of x is 125 plus x to the cubed, so the first derivative is well, actually the function equals 5. I didn't write that down, but the first derivative equals 1 over 75, and the second derivative is negative 2 over 28,125. Third derivative is 2 over 2,109,375, and the fourth derivative is negative 16 over 79,101,000, or let's see, 7,910,000. Oh, whatever, it's a big number. So the final form of the Taylor series for this function is 5 plus 1 over 75x minus 1 over 28,125x squared plus 1 over 6,320,125x cubed minus 2 over 2,373,046,875 x to the fourth, which should be like right here, but I didn't write it down, and that continues and gets bigger and bigger. And then for the function of f of x equals 1 over or x to the 1/3, centered at 125. The derivatives are pretty similar, so similar that they're the exact same thing. And then the Taylor series is just a little different, with it being 5 plus 175, and instead of x cubed, or x in this case, it's just x minus 125, and then as you go forward, it's just x minus 125 squared. But the derivatives are the same, and the Taylor series is the same, except for the function. You just have to add it on because it is not centered at 0. So I went into Desmos and I graphed it. And then, so this is the series not centered at 0. So this is the one that's centered at 125. This is the B. And then this is the same function graphed centered at 0. So as you can see, they're the same lines. They have the same table values. If I can pull those up. Oh, I guess they don't. Alright, they don't have a table because they're lines and they don't have tables. So if you compare the two approaches, how are they equivalent? I'd say that they're pretty equivalent. They're pretty much the exact same. You get the same thing except the lines just at a different center. So really they're not different at all. But I'd rather do A if it's worth anything, just because I found it easier, just because it has a simpler approach being centered at 0, because it's nice and perfect, just as we like it in math. And that is my exploration series.